for Meetup. Sorry for being a few minutes late. Had, as usual, a few technical issues to overcome, but that wouldn't stop us at all. Of course not, because the one and only Ibra is with us today, and he's about to talk about securing your data using Postgres.
Yep.
So without further ado, I want to hand over. I had some echo, some weird one. Want to hand over to Ibra. Not sure what this was. I hope for Ibra everything works out perfectly. So handing over to you.
Yep. Thanks, Kai. So we have Edith and Mario with me. So welcome everybody for our monthly developer meetup. So today we will discussing about how to secure your data using PostgreSQL. So my name is Ibrahim Ahmed and I'm working in the Percona. So let's start. First of all, today's agenda is about we will discuss about the what is a database security. So in general, we will discuss how we secure our data, what need to be learned, that everything about the security, that specifically the database security, and in that we have some module that the authentication, authorization, and accounting. It's just a triple A. Then we will touch the encryption and some security best practices. And then we have some session about the QA. So database security. Whenever we are talking about the database security, people usually think about that they have to secure their data only where data node where their database reside. But it's not the case. You have to secure the whole infrastructure, and that infrastructure involves your network, your host computer, your database, your application, and actually your data. So these are five pillars of your security. If you have any loophole in one of the in this pillar, then your database is not secure. So when we are talking about the network, you have a network where your database computer or node is there, and we can call it node, and host is in.
I guess we have some network issues and lost Ibra.
Yeah, looks like we lost him. I can hear him.
Okay, yeah, I have him marked as red, basically connectivity-wise. So having a poor connection. Perfect. That works out perfectly. Love it. This is live, right? If you're on air, being live, now I'm getting more familiar with the tool at least, having this under control, which is great. Let me ping him to see and let him know. I guess he's talking into the void, I guess.
Yes, probably.
Or he had some outage. Let me check. Okay, pinged. Getting more. So I informed Ibra. I hope he's back in 10 seconds after his connection is basically established again. I could juggle. I can do that, but not sure this would actually help because people are waiting for Postgres content.
You get me?
Now you're back, Ibra.
Yes.
We basically lost you for the last 1.5 minutes.
So I was talking about the securing your network. Then we need to secure our host computer where your actual database resides. So if your host computer is not properly secure, then your database is not secure. Then we come to the actual. We are now talking about your database like PostgreSQL, MySQL, any database. Then you have to secure your database. Then you have to secure your actual data. Now it's come to your actual data. You need to secure your actual data. Then if your the last the application, if your application is not secure, somebody can Jim, into your application, it's not secure, then your data is not secure because you are coming from the right network to the right host to the right database, and your database is secure, but your application has some loopholes, so somebody can store your data from that application. So you need to configure all these five pillar of to secure your data. So ultimately, you are securing your data, but you have to be careful and manage all these pillars properly. So in this, the first the in the AAA model, that the first thing is authentication, and then authorization, and then accounting. The first one is authentication. That means which user are allowed to access the database. So you have some list of a database and list of a user that are allowed to access the database, and that's called authentication. And authorization means what is the user allowed to do. So now you have given the access to the user to log in, that's authentication, and what a user can do, it's called authorization, and what user did, it's called accounting. So these are the three things. First, who can log into your database, and what a user can do, and what user did. So these are the three things we will discuss in next slide. So authentication, it helps to ensure that only authorized user can log in. So it's usually happen when you are providing the username or user ID and the password. So these are the all things are written here. I'm not just discussing and reading that stuff. The basic concept of authentication is you provide a mechanism to the user to log into your database, and that called authentication. And if you are not allowed, it will deny the access. If you allow, it will let you log in. But what can you do? In later slide we will discuss that. So now we have discussed that what is the authentication. So authentication is just writing a user and a password as a user perspective. But internally in the PostgreSQL, there is a whole lot of things is happening underneath. So like PostgreSQL provide three kind of authentication models. The first authentication model is internal authentication. In internal authentication, that means PostgreSQL have some code that will authenticate a user. That the first one is trust. That means that is trusted user. We can log in, but it's a weak security. So the second user, you just provide a username and that or IP address or something like that, and put reject. That means that user or that IP address is rejected. Then we have a MD5 hash authentication, and then we have a scrap authentication, and then we have certification based authentication. And this doesn't require any external tool. The PostgreSQL provide this mechanism. You just install PostgreSQL, use any of these authentication method, and PostgreSQL will you authenticate you, let you in or not let you in. That's the binary value. It will allow you or it will not allow you. So then the second authentication is OS based authentication. So in that case, when you enable the OS based authentication in PostgreSQL, PostgreSQL just transfer your level of authentication to the operating system, and operating system will decide that you are the legal user or not the legal user. It will allow you or disallow you. So in that case, you just put username password in PostgreSQL, and PostgreSQL will pass that information to the operating system, and operating system will accept it or reject it. And there we have three more options. Like if you configure the PAM or peer or IGEN, you can configure either of these three options in operating system that in PostgreSQL, and tell PostgreSQL that authenticate using the PAM, the peer, or the IGEN type of authentication by the operating system. Then, if you don't want to authenticate using the PostgreSQL and you don't want to authenticate by the operating system, there are some third option is available. That is an external authentication. That's not based OS based, is not PostgreSQL based. That is an external tool, external server is running somewhere over the network or somewhere it's running, and you are just passing that information, username and password or something like that, credential, to the PostgreSQL, and PostgreSQL will pass that information to that server, and that server will authenticate based that it's a legal user or not legal user. Like the LDAP authentication, like the radius authentication, the JSFI and SSPI. So that server are configured like LDAP server is configured somewhere else, and you just put that information in PostgreSQL, and PostgreSQL will pass that information to the LDAP, and LDAP will return that if this is the legal user or not the legal user. So these three kind of authentication model PostgreSQL provide: the internal, the OS, and the external. So authorization. So we have discussed that user is authenticated. So if user is not authenticated, that we are done. That you are not allowed to come here. And then comes the authorization. If user is logged in and their credential is correct, that he is able to log into the system, then this happens that this user can do and this user cannot do. So do and cannot do. So that's decide the authorization system decide what a user can do. So there is a three level of authentication authorization in PostgreSQL. A user level authentication, that this user can do this and this user cannot do this. Like this user can select and this user cannot select. This user can delete something and this user cannot delete something. So you can configure that what the privileges has that user. And secondly, the second option is object level authentication. In object level authentication, you put some security level onto that object, that this database uh, is this object is secure, and you can revoke and you can grant some privileges to the user that this object is accessible or not accessible, and that's called object level authentication. In user level, you provide the information to the user can access these things. In reverse, you see there are objects and you can hide, you can restrict a user, that user can do that and user cannot do that on that object. That's called object level authentication. So normally databases has this level of authorization that user can do or user cannot do, and this object is accessible and this object is not accessible. But PostgreSQL also have one more level of authorization, that's called row level authentication authorization. Sorry. So what is the row level authorization? In a row level authorization, you are allowing a user to select from a table. A user can access a table. Both user can access a table, but he cannot see all the rows of the table. So he has some privileges to see some rows, and he has some restriction that he cannot see some rows. So it's a row level authorization. So here I just give you the answer. The first, the user level authorization; second, the object level authorization; and third, the row level authorization. And user level authorization, so you have a role, you have a user, and you have a group. And similarly, in object level authorization, you have a two commands: grant and revoke. That this object is accessible and this object is not accessible. You grant the privileges from the object, and you can revoke privileges from the user. So then the row level authorization, PostgreSQL have row level security. So we will discuss. So grant and revoke, if you see that you just create rows and you just call on accounts to manage, and you can select that. And you can revoke, delete on account from manager. So you delete, revoke, delete privileges from a user. Like here, permission denied for table accounts. We want to delete from this. So you can grant and you can revoke the privileges from an object. So that's really simple. So you can do that with Slack, you can do that with update, you can do whatever you want in that within the limit of PostgreSQL. That's really interesting. People really interesting in that. Interested shows interest in that. That how the row level security works. The row level security works in the sense that if you have, like, I have created a table, it's called create table accounts, and then alter the table. And this is the important statement: that create policy accounts on to using manager is equal to current user. So I have created a policy on a name account manager on account table. That this is the name of the policy and this is the table. So I give the whole permission to the manager's user. The manager can access everything. I give you the full access. So if I execute any statement here, it will just select you all the rows. But here I have inserted two rows, and then I select static from account. You can see manager, Percona, who, an example. You can see all the things is happening here, and I log in using the manager table. Previously, I logged in using the PostgreSQL, which is a super user. But here I have created a policy or manager user where manager is equal to current user. If manager is the current user, I created a policy. So here I select static from accounts. I logged in using the manager user. You can see I can only see the manager's rows. Because you can see the manager is equal to current user. It matches this statement. So you can see this row. You cannot see any rows which is the EMT. So there are two rows, but that manager user can access only where manager is managers actually. It cannot see any other rows. So we added a policy on PostgreSQL table that a specific user can see a specific rows in the table. So manager have the privileges. You can see that I gave the grant everything on accounts to the manager. But when we are talking about the row level, you can see only the subset of rows, not all. So I'm in. Everybody can hear me. So I'm not lost. Kai?
Yes, you are there. We can hear you. Everything's fine.
Yeah, I'm just checking. I'm just checking. So database. So now we have discussed the authentication, authorization, and now the accounting. And usually accounting means what user did to the system actually. So because we already logged in, the user have some access, but at the end we want to see what a user have done to the database. So that can be done database logging, and there is a three kind of logging is required. So network logging. So whenever something happened to your database, you first check what happened to the network. It's some kind of an attack, something like to just check the network log. Then you check your application log. Something happened application. If you're happening in an application, just check your application what happened to your database. But when we are talking about the database logging, PostgreSQL provides some database logging mechanism. We will see that what's the database logging. So usually we also call it the monitoring. It's logging and also call it a monitoring. So what kind of a PostgreSQL built-in logging mechanism in PostgreSQL? So first the logs. Oh, sorry. First, the log. There is a CVS log. So just configure that there is a log which is the CVS log. If you see on the right side, you can see the information is a comma separated values where there are time, date time, and you can see the user, the database name, and the select and the duration. So this kind of a log, you can see what happened, which user has done update, which user has done insert, which user has delete, at what time of the day, and how much time it takes. So then there is another log. This is called a syslog. In a syslog, if you configure the PostgreSQL to show the syslog, you can see the syslog. You can see the insert into. You can see all the information, the PostgreSQL, the log, the duration, the insert into my table values. So you can see the values. That's a CVS log. So it can also show you the connection and disconnection information and all the important information. You can see that here. Then you have an event log. The event log, if you configure the event log, then you can see the statement. You can see this kind of statement that insert into my table values this, and you can see the disconnection, the time, the user, the database. And Along with that, this log, PostgreSQL also provides some statistics and monitoring tool. It's a mixed kind of a tool, which is called a pgstat statement. It's a config module for the PostgreSQL. So where you can see, you can actually view of pgstat statement. You need to create an extension in PostgreSQL before using that. When you create that, you can see that by selecting the pgstat statement, all the information, user ID, DB ID, query. There's a lot of information there. I think it's 35 to 36 columns there per query. You can see that, and how many times this query executed. So that's a manageable way to see the logs actually. There, these are the built-in. This is the built-in monitoring and logging solution. But there are third-party tools. Actually, the PGStat Monitor. PGStat Monitor is an extended version of PGStat statement. It provides uh, almost double the information that PGStat statement provides. Its mechanism is changed that it shows the information in the bucketing, not like the PGStat statement. You have some timing buckets. Within the bucket, you can see the aggregate values. So that's a really cool tool. And as a Percona's tool, you can always download it from GitHub Percona PGStat Monitor. You can see the first line here, this one, and you can download it. You can use it. It's quite cool tool. You can always it's show you the real time monitoring and logging and statistic information all in one place. So then there is another tool that is called PG Audit, and you can also download from second quadrant. Audit trigger actually, and sorry, the audit trigger. Sorry, the PG audit is from PG audit, and you can see that from here. And the trigger is this one, audit trigger. So these are the external tools. There, I have not listed all the tools here. There, you can go to the GitHub. Some other you can find many, but I listed down some of the main one. So there are some.
Ibra?
Yep.
Given that this is an interactive presentation and we allow questions, I could read out the question from Charlie out loud, but I have seen him that he's in here directly. So I will just basically bring him to the front. Hope he did not fall asleep, so he can ask his question directly to you.
Okay.
All right. I was wondering, Ibra, if it's possible to have filters in the log. For example, if we have some sensitive data, is it possible to put a reject or something that we can have filters in the log for not to log in, to not send some of information to the log, or we need
Yes.
a...
Yeah, you can configure that. You can configure that in PostgreSQL.conf file. You can configure that which kind of information you require. Like you don't want to show the username. Just there is a placeholder. You can put the placeholder. The user should be there or not. So you can configure your log properly. Like if you want to show the everything, put the placeholder. So there is. I have not. After the presentation, I can show you the actually filters actually, where you put the placeholder for database name, username, timing, query, whatever you want to show and what you don't want to show. So there is a filters available.
That's cool. It's because it's very important to have those things, right? Sometimes we want to prevent some sensitive information to go to the log, and knowing that Postgres allows us to do it like in an easy way is pretty cool. Thanks.
Yeah, like in this example, you can remove that user one. Like user one, it will show you the time, my DB select, and it will not show you the user if you don't want to. So
Gotcha.
yeah.
Thanks, Ibrahim.
And then we have covered the AAA, like authentication, authorization, and accounting, which is usually called the logging and monitoring. Then we are secure in that data. But what happens if somebody go to your system and just pick your blog, because the data is written on the disk is not encrypted. So that's the problem, because if somebody is not coming from your database, he doesn't want to log into the system, but he go to the file system and just open the file. So he has some kind of a tool and something like that, and he just open that and use that. And it's not going from your route; it's going from the other way. Like he install another PostgreSQL and shut down your PostgreSQL and use his PostgreSQL binaries on your data directory, and he can use that because he doesn't need to log in on that system because it's own system. So, but the problem is the data is not safe. The physical data is not safe here. So that's called encryption at rest come here, because you encrypt your data. So whenever you come from that PostgreSQL, it only accessible from there. If you come from external source, you cannot access the data. It will show you the encrypted data, and that is called the encryption at rest. So you are encrypted your data within the database. So your database directory actually encrypted. So we will discuss that the level of granularity of the encryption. We will discuss in the next slide. So there are four kind of. Actually, there is a five. So I listed as a four, but because the database provide four kind of granularity here. The first level, which is zero level, we can say that you encrypt your disk. You just encrypt the whole disk, and you have the key on your hand. So just encrypt it and use it. Install the PostgreSQL on that and use it. But it has some pros and cons in that you don't want to encrypt because it will slow down your system, because you are encrypting everything. Even you have a logging and you are encrypting the logs. If you have some data which is not critical, not sensitive, and you are just encrypting because your disk is encrypted and you are just wasting time, your database is slow down. So here comes the level 1 security of PostgreSQL. Like this is called cluster level encryption. By the way, cluster level encryption is not supported in PostgreSQL. Database level encryption is not supported in PostgreSQL. Table level encryption is not supported in PostgreSQL. PostgreSQL only support column level encryption. So you can just encrypt your column. You cannot encrypt your whole cluster, all the database. You cannot do that. You have, if you want to do that, just use your operating system encryption mechanism. And if you want to encrypt your one database, it's not possible. You encrypt your one database is critical, just encrypt it. You can't do that in PostgreSQL. But the work in progress, even Percona is planning to have some database encryption that is called TDE. So we are planning to do that. And community is also working on that, so we can provide cluster level, database level encryption. And somewhere in a table level encryption, you just encrypt some credit confirmation has only the column level encryption, and that's a country module which is called a PG crypto. Using the PG crypto, you can encrypt your one column of table. So how to do that? We will discuss that, how to do that. Actually, the file system encryption, it is not a database part of the database, so it's called file system disk encryption. So I just highlighted here because it's not part of the database. It's a part of the operating system. There is some external paid, unpaid tool, according to the like the BitLocker, the Veracrape, the firewall, logs, DMCrape, and there's a lot. So it just listed some of them actually. From the operating Mac OS, for the Linux, for Windows, these are the names. You can use that. So I'm not encouraging to use any of this because I'm not using that. So I discussed that we have discussed the what kind of encryption a database should have, but PostgreSQL have only the column level encryption. So uh, what is the column level encryption? That like select ID, name, and PG crypto. Actually, the column level encryption, it has a function PG sim decrypt and PG sim encrypt. We just decrypted this information. You provide the key, and it will encrypt and decrypt the value. And you can see that actual value is bar foo, and you can see the ID and name here. You can see that. You can see this value. And this is the joke that I got your message, but I cannot read a word of it. So it's just a joke. You just show something. I can see your data. I just see this data, and but I cannot read it. So just read it. Just it's just the value, so you can't read it. Even if you go to the disk and you just read that column, area of that column, you read it, you can see that this information is there. You need to decrypt that. using the key, like we am using the AES key. This is the word actually I'm using for the key. So if you don't know that value, you cannot decrypt that. So we discussed that encryption at rest. So there is another level which is called the encryption in transit. So encryption in transit mean when your data is traveling from client to database. Oh, sorry. When your data is traveling from client to database or client to database and database to client. When this data is traveling, like you are inserting something, so it's going to the database, and when you're selecting something, it's coming to Postgres to client. So we need to encrypt that too, and in that area, Postgres will provide your SSL and DNS, and your data is encrypted. It's based on some encryption keys or something like that. So it's secure. Postgres could fully support that. So TDE, data at rest, is not fully supported in PostgreSQL, but in transit database, your database is secure. So you can always use that. So at the end, actually, there is that's the thing. Then, what is the best practices in security? So in general, if you are discussing in general, in databases in general, so what should you do? Use strong, unique password for your database. If your database is secure, your network is secure, everything is secure. You provide everything, and you just put username, your name, and password is ABC123. So where is your security? Everything is gone because he can access everything because your password is not there. So enable SSL TLS for the network connection. So it's secure your data over the transit. Use firewall. Actually, that's really important. Use firewall to deny directly access SSH access to your database server. Don't give that access to the database. Even not the SSH, don't give that access to your user to log into your database. They should log in through your application. If you are application developer, just give the application to log into your database. Don't give the direct access to the user to log into your database. Always you enable the logging and monitoring log and check that. Regular update PostgreSQL because PostgreSQL continuously, it's not just a PostgreSQL, every database is working on their security loopholes. Database is a software. It always has some security loopholes. Even it's not have a security loopholes. It's using the libraries like OpenSSL, and sometimes OpenSSL have encountered some security loopholes, and you have to update OpenSSL version, regularly update that, and use encryption for the sensitive data. Right now, you can use that on the disk. There are some portion that you can use that, like you can create a table space encrypt, and table space should reside the some another disk, and that disk is encrypted. That's the workaround of the data encryption at rest. These are the just a general way. But when we are talking about the PostgreSQL, always use a firewall to protect against the attack. That's the one way. Don't give access to all. Use a private list of IP address. So whenever you said that, normally people give the all the access because they are really worried how to configure the each IP address to give the access. Like if you want to give to the people, 100 people to access your database, or you say how I can configure the 100 IP address. Give the attention, do that, write the 100 IP address and give them the permission, and denied all other IP addresses. If you are just lazy and just give the access to the whole network, put static here, or just the network, or the everybody can access your IP address because you are worrying, you are lazy enough to type the 100 IP address, and you don't want to create the subnet on that, lazy enough, it's a security loophole. And never ever expose your database 5432, which is example 5432. This is default PostgreSQL to the internet. Don't give that port to the internet. Always ask people to come to your application, and then in your application you access that. Your application will reside in your system network, and that in network you can use the database. So don't allow the client application, they install their own computer to directly communicate to your database. Don't directly allow login to your database. I already told you it's for the all database, and PostgreSQL also. Don't allow to directly SSH or PSQL can connect to the database remotely. Don't give that access to. Secure your backup. That's important. People usually have very restricted policies over database. When they are creating database, they just put that into backups and just put somewhere else, and anybody can use that. And that's another important. The PostgreSQL conf, there is a listen address. Don't write static there. Put the listen IP addresses on which it can listen. Don't put the static that listen on all the networks. You have 4 or 5 networks on your machine you have, and only one network needs to access the database, but you are lazy enough to just put static there. All the network can access your database. Oh, it's security loophole. Just if you need a one database, one network can access your database, just put that network address here. Don't put static there. Every network can access your database. So that's the security best practices you need to figure out. It's just some of that. There can be many according to your thoughts. So now, thanks everybody. So we can have some question session. So I'm just stop sharing here. So I can also see the people here. Yep.
Thanks a lot, Ibra. That was really, really cool. Let me check, first of all, if there are more questions that made it into the YouTube chat. There was only the one from Charlie, and I put him already on the spot. You do have a question? Of course, then I'll unmute you. It's your turn.
Yeah, I got a question from Michael Bancho from Percona. Yeah, he asked about OS encryption. Like usually on MySQL, before MySQL has TD, we usually use LUKS from OS encryption. Do we have any recommendation for the type of LUKS encryption for Postgres as well?
Yeah, I don't understand your question properly. If you're asking about the OS authentication, you are asking
No,
about
the encryption. The encryption.
Actually, there have a lot of problem with the OS level encryption. So, like if you do that, the major problem is the performance. The major problem is performance because you are encrypted everything, even the logs, the configuration, everything. And I see people don't like it just because of the speed. Because if you are filling your database with a lot of things, and your IO is the main thing, and everything is coming from that encrypted and decryption policies. So usually in PostgreSQL world, people are really worried about that to installing that. So what they do actually, they create a table space outside the data directory and map another drive, create a table space on that drive and encrypt that drive only.
Okay.
That's the workaround.
Yeah, no, that makes sense. That makes sense. And for the type of encryption, do you have recommendation? Like usually people use LUKS for encryption on Linux. Like, is it also good for Postgres?
Yeah, it's actually it's all independent. Actually, because PostgreSQL doesn't provide that at rest. So we are doing the file system level. So there is no recommendation from PostgreSQL right now. It's all about their own need. How much secure you want your database? Because if you secure more, then it will cost the performance. If you secure less, then so it's all about your need. PostgreSQL is not recommending anything at that point.
Okay. Gotcha. Thanks, Brian.
Okay. Any more questions from anyone? Maybe, I'm not sure if Edith or someone else, Charlie, you've seen another question somewhere? Just want to make sure those are addressed.
Question, maybe basic question, but it is encryption chain if I am using containers, Postgres in containers, something chain, something special to do?
No, actually, it's PostgreSQL doesn't provide the encryption. Actually, the encryption. So it's all about the OS. If OS support that encryption, so you can use that. So it's all about. It doesn't have anything with PostgreSQL.
Okay, thank you.
Okay, let me check one more time. No further question on YouTube. Checking the other channels. Haven't seen anything on LinkedIn. Not that I get all the complaints afterwards because I forgot to ask those questions live. Now is your chance. So I call out Charlie the last time for the last time. It's your chance right now. It's live on air, so you can ask all the weird questions. If not, I'm also fine wrapping up, but just want to make sure you're fine.
No, it's just a comment back here from Michael Benchov that he says that he got the point that linking the table space to encrypted driver, that would be a good alternative, probably good alternative for most of the people, right? So on that note, I think I also a good practice, even for to split the I/O, right? Is having different disks for the logs, the WAL files, and so we can try to mitigate the performance of encryption, right? So we can still have those different drivers encrypted, but as there are different ones, we can kind of mitigate a little bit the performance penalty. No, that was a good one. Thanks.
Awesome. Then I would like to thank Ipra again for this good conversation and answering all the questions that we had. And I'm not sure if we lost him again. You're having a little bit problem with the connection from time to time.
Yeah.
Now he's back.
Yeah, I'm back.
So
I'm listening. I was still. It looked like
okay.
Failed.
So then again, I hope you basically heard my kind words. Thanks again for the great presentation, for spending the time with us, thanks to everyone who basically joined on all the various channels that we distribute. It was really fun, and hope to see you next time. Enjoy the rest of the day, and bye everyone.
Bye everyone.
Thanks everybody. Bye bye.